Metric students, I hope you're having a great day. Welcome back into our lesson video. It's a re-up for mid-latitude cyclones. Yes, it's a re-lesson for mid-latitude cyclones. Yes. Yes. So please, guys, don't forget to subscribe. Don't forget to subscribe to the channel. Please, don't forget to subscribe, guys. I repeat, don't forget to subscribe. If ever you're watching now, please go and subscribe. Please just click that red subscribe button. Please, the red one. Okay. Yes. Please, guys. Okay. Um. So the vital concepts that we need to know and discuss today is that I'm going to introduce you again to mid-latitude cyclones and discuss the stages of development of the mid-latitude cyclones. Okay, yes, the stages, as you know, that we have initial stage, we have mature stage, and we have occluded stage. Okay, whereby the cold front takes over the warm front, and etc. Cold front conditions, yes, going to be discussing also cold front conditions. As we know that the mid-latitude cyclone is dominantly with the cold front, with the cold weather weather conditions and so on. The warm front also, you know that we have two fronts for mid-latitude cyclone. Yes, the warm front and the cold front. So we're also going to discuss more about the warm front conditions and so on. The cold front occlusion, whereby the cold front overtakes the warm front, and as well as the warm front taking over the cold front. The warm front occlusion and so on. Okay. Yes. The warm front occlusion is whereby the warm front takes over the cold front. The satellite photo of mid-latitude cyclone. Yes, and look for the satellite photo for mid-latitude cyclone and see how it looks like, in real life, and so on, without being drawn or illustrated using a synoptic map, like seeing it physically. Okay. The synoptic map of mid-latitude cyclone. So this is the map that is mostly used to illustrate the mid-latitude cyclones during examinations. Okay. Yes, let's go down to the introduction. Okay, so for the introduction, so mid-latitude cyclones, these are the low pressure system or the low pressure weather systems that occur in mid-latitude, okay, regions, okay, of the earth, usually between 30 degrees south and north of the equator and 60 degrees south and north of the equator latitudes. Okay. Yes, so the very important thing is that you must know that mid-latitude cyclone, it's a low pressure system. Okay. Yes, and where it occurs in the mid latitude regions. Okay. Yes. um yes, in subtropical regions and so on. Okay. Yes, so between 30 degrees and 60 degrees latitude north and south of the equator. Okay. Yes, so they are sometimes called temperate cyclone, I mean extratropical cyclone, mid-latitude cyclones, as you know, frontal depression, or wave cyclone. Okay. Yes, so they have other names, or we can call mid-latitude cyclones in using other terms such as temperate cyclone, extratropical cyclone, frontal depressions, or we can say it's a wave cyclone. Okay. Yes. Okay, so this is a low pressure system um whereby it forms basically in 60 degrees south of the equator and north of the equator as well. But please, guys, let's be based on south of the equator, eh? Yes, let's please be based on south of the equator, but as well as in north of the equator, it also occurs in 60 degrees latitudes. Okay, but please, let's be based on 60 degrees south of the equator, so that you don't get confused. Okay, yes. So um, yes, so it forms in the subpolar front at 60 degrees south of the equator. Okay, yes, it forms there in that front, whereby the westerlies meets the polar easterlies. Different air masses meet there. Others from the tropical region which have warm moisture, which is less denser air. Okay, the westerlies that are from the tropical regions, they meet the polar easterlies, which are dry and dense, very cold. Okay, yes. So the front is formed by these two air masses, or by these two planetary winds. Okay, so they are sometimes called, yes, um the system is made up of cold and warm front. So the system is made up of cold as well as the warm front. Okay, yes. As you know that there was warm air as well as cold air met and form this midnight cyclone. Okay, so meaning that there will be warm front and a cold front. So the cold fronts reach South Africa mostly in winter. So the cold front reaches South Africa in winter, meaning that this midnight cyclones occurs when in winter, not in summer, not in spring, not in autumn. Okay, in winter, when all the pressure belts and wind systems move slightly north. Okay, what does this mean? This basically means that um, this is whereby the equator moves upwards, or all of the pressure belts, all of the lines of latitude in the world, they move upwards, okay, and southwards, okay, up and down. Okay, so normally 30 degrees south of the equator, whereby these midnight cyclones occur is just below South Africa, but in winter these latitudes moves northwards. Okay, yes, up, as well as the equator moving far from us. Okay, that's why we experience winter, because now equator is very very far from us. And also, if ever equator moves up also 30 degrees south, all of the lines of latitudes also move up, meaning that 30 degrees south of the equator is going to also move up in winter. Okay, be dominant in South Africa, lies through the land of South Africa, the earth surface, okay, of South Africa. So this is whereby we have this opportunity to experience this midnight cyclone. But the part here in South Africa that is mostly affected by this midnight cyclone is the southwestern Cape. Okay, yes, it's Cape Town, and that is why Cape Town receives winter rainfall. Okay, yes. So this is why the southwestern Cape receives winter rainfall. Yes. So the rain is brought by cold fronts passing over this area, passing from east to west. Yes. So midnight cyclones, they move from east to west. That's their directions, meaning that they are also associated as westerly winds. Okay. Yes. So they move from east to west, and you know that South Africa is situated on the east side, on the east of the Greenwich meridian, meaning that yes, it makes sense now if ever this midnight cyclone moves from east to west. So the warm front is bent southward away from South Africa. So the warm front, as you know that this system consists of the warm front, cold front as well. If the warm front is also there, meaning that yes, South Africa must also experience the weather conditions on the warm front. We must receive warm in the south of the Western Cape, must receive warm, must see cirrus clouds and so on. Okay, but it is now bent away from South Africa. So when this mid-latitude cyclone reaches South Africa, this warm front is bent away from South Africa, meaning that the cold front is the one that is passing through South Africa, the one that is being experienced, and so on. Okay, but we're going to discuss the common core weather conditions of this fundamental cold front. Okay, yes. So that's how it goes. That is why this warm front is bent away from South Africa. Okay, let's go down. Okay, so now let's discuss the stages of development of the mid-life cyclone. Okay, we have initial stage. As you can see, we have initial stage, we have mature stage, which is our second stage, and lastly we have occluded stage. Okay, so let's go down and see and discuss. So for initial stage, which is there up there, okay, so I can also see for initial stage the pressure differences exist between the warm tropical air. The warm tropical air is the air that is from the westerlies, okay, that is brought by westerlies. Okay, yes, westerlies come with the warm air from 30 degrees south of the equator and north of the equator as well. Okay, those are the westerlies moving southwards. Okay, yes, as westerly winds. Okay, yes, to join the cold polar air, resulting in pressure gradient around polar front. Okay, so now let me explain what a polar front is, what a front is, by the way. So a polar front is I can say it's an area, okay, that is caused or developed by the meeting of different air. Okay, yes, of different air, of differences in the air, meaning that if ever cold air meets the warm air, there will be a front that is going to be formed, because there are two different MSs met there. Okay, yes, meaning that now the cold air, which is dry, very very dry, polar regions are very very cold. Polar regions have dense, dry, cold air. Okay, there's high pressure there, meaning that that cold air that is from there, the polar easterlies, when they meet these westerlies from the tropical regions, since they are very very cold, they are going to be obliged to get underneath the warm air, forcing the warm air to rise, because you know that the warm air is less denser, and the warm air is have moisture. Okay, have high moisture content. Is going to rise. Okay, and form clouds. That's what a front is formed. That's how a front is formed. So also another example, which is about a front. We receive our conventional rain, or our frontal rain. Yes, the frontal rain through a front, whereby there's warm air that is in the surface, and the cold air meets the warm air. The warm air is obliged to rise, which have moisture content. Okay, yes, obliged to rise and form clouds, and that is going to result in a rain. Okay, also a moisture front, also a line thunderstorm. Okay, line thunderstorm is also a moisture front. So that's what a front is, because that moisture front is formed when the South Atlantic um, anticyclone air from the Atlantic Ocean, which is cold, very very cold ocean, and dense air. Okay, dense cold air gets in the interior of South Africa, and the South Indian anticyclone from the Indian Ocean, which is warm Mozambique current. Okay, very very warm, meet this cold air from the cold Bangalore current in the interior of South Africa, and the front is from there. That's how the moisture front is from. I think you understand the concept of front, yes, as well as the polar front. The polar front, this is whereby this cold air from the polar regions, from these polar easterlies, meet the westerlies that are originating from the tropical regions. They meet each other. You see, different air masses. The other air is warm, and the other air is very very cold and dense, resulting in a front. I think you now understand the concept of front. So the pressure differences exist between the warm tropical air and cold air, resulting in pressure gradient. Okay, yes. So due to a disturbance in winds high in the atmosphere or mountain ranges, wave forms. Okay, yes. So now a wave is formed. um, I can also say that the air begins to be unstable and so on. Okay, yes. So a cell of low pressure begins. So now a cell of a low pressure begins. So now a front is formed. A disturbance in winds high in the atmosphere is now unstable. So the wind is now unstable. The wind is moving too fast. It's starting to move and so on. And now a cell of low pressure that is called a mid-light cyclone is formed. Okay, yes. So let's move to the mature stage. Okay, okay. Let's go back to our picture. I forgot to show you there in the initial stage. As you can see that this is the warm air and the cold air. Okay, they meet to each other. Okay, yes. So as you can see that the warm air is on this side. Okay, is on this side, the warm air, and the cold air underneath. Okay, yes, pushing this warm air to rise so that it can form clouds. Okay, a front, polar front. Okay, and the instability uh begins to start in the atmosphere of the winds. Okay, yes. So the spiral of the movement of the air in a cyclonic way begins. Okay, so that's how it goes. As you can see, the pressure is 1008 hectopascals. Okay, yes. But this is northern hemisphere. Okay, so the other thing that you should know is that in mid-light cyclone it moves in a clockwise direction. Okay, in southern hemisphere, but in northern hemisphere this is southern hemisphere. Okay, this is a mid-latitude cyclone in southern hemisphere. It moves in a clockwise direction. Okay, in a clockwise direction in southern hemisphere. In southern hemisphere. So in northern hemisphere it moves in an anti-clockwise direction. These are things that you should know. Okay, this is northern hemisphere. Okay, it moves in an anti-clockwise direction. Okay, this is N. Okay, so sorry okay, so this northern hemisphere it moves in an anti-clockwise direction. Okay, yes, so let's move. Okay, now let's move to the mature stage of this mid-light cyclone. So the air flows around low. Okay, so the air flows around this system. Okay, this low pressure system in a clockwise direction in southern hemisphere, what I have just showed you, and anti-clockwise direction in northern hemisphere, meaning that all the countries that are experiencing, just like South Africa, particularly in Cape Town is experiencing mid-light cyclone. Okay, in each and every winter, meaning that it's going to move in a clockwise direction. It's moving in a clockwise direction. Okay, because it's in the southern hemisphere. You know that South Africa is in the southern hemisphere. Okay, south of the equator. So all of the countries that are south of the equator, the anticyclone, the mid-latitude cyclone is going to move in the clockwise direction, and the countries that are upper equator, meaning that the north of the equator, all of the countries that are experiencing, all of the countries that are between 30 to 60 degrees, meaning that they are experiencing this mid-latitude cyclone. The mid-latitude cyclone is going to move in an anti-clockwise direction because it's in the northern hemisphere. I think you understand, guys. So the polar front forms cold and warm front. So this polar front, okay, in 60 degrees, okay, in 60 degrees south and north of the equator is going to form a cold and warm front. So now in the mature stage, we can clearly see that the mid-latitude cyclone is there because there is we can physically see that there is warm front and there is a cold front. So this is why it's in mature state. It's very very strong. Okay, yes, we see cold front and warm front. So during your examinations, if ever you see a mid-latitude cyclone, okay, or a synoptic weather map, you see a cold front and a warm front, or just a cold front and so on, you should know that the mid-latitude cyclone that you see there in your paper, it's in mature stage. Okay, meaning that it's on its dominant stage. It's very very strong. Okay, yes. So it's well developed. Yes. So the fronts divide area into warm and cold sector. So so these fronts, okay, these fronts, we have cold front. Let me make an example. This is cold front. Okay, this is how to draw a cold front. You put something, if ever you see something like this is a cold front. Put something like a triangle. Okay, yes. And this is a warm front. This is a warm front. So a warm front is like round, okay, like a siren of a car police, okay, of a police car. Okay, on ambulance. So so the front divide area into cold and warm sector. So this is going to be a warm sector because this is a warm front and this is a cold sector because this is a cold front. Okay, yes, that's how it goes. Let me remove. I was just showing you. So that's how it goes. So whenever you see a cold front and a warm front, you must know that just behind or next to the cold front there is a cold sector, and there are weather conditions there that are under this cold front. Just behind the warm front, you must know that that's a warm sector, meaning that there are common core weather conditions um, under the warm front. Okay, yes. So let's move down to occlude the stage. So occlude the stage. Move this occluded stage. So in this stage, the cold front overtakes the warm front. So in this stage, this is whereby the cold front overtakes the warm front, meaning that the cold front is being the one that is dominant in this system now, because the system is made up of the two fronts, which is cold front and the warm front. And when this cold front overtakes the warm front, meaning that mostly this system there will be cold conditions. Okay, because the cold front is dominant. Okay, resulting in only cold air on the ground, meaning that yes, that's how it goes. Okay, lighter warm air is pushed up, meaning that the warm air is now lifted upwards. Okay, yes, meaning that the warm air is lifted upwards. Okay, if ever the warm air is lifted upwards, leaving the cold dense air and dry air on the ground. Okay, yes. So mean that if ever you're on the ground and experiencing this mid-light cyclone, you're going to receive or you're going to experience cold air. Okay, yes. Must wear warm clothes and so on. Okay, okay. Let's move down to cold front conditions. Okay, so now we're speaking about these cold front conditions. Okay, this basically deals with what is happening on the cold sector. So the cold front conditions, if ever you're experiencing cold front or you see the cold front in your in the television or in your examinations, okay, yes, you should know that the cold front or the weather conditions that are being experienced under the cold front is that the temperature decreases, meaning that the temperature becomes lower. Okay, so the temperature becomes lower, goes down, decreases. You know, cold air has low temperature. Okay, 0 degrees, -1, -2. The warm air is an opposite. The warm air can be 27 degrees, 28, 29. Okay, yes, because it's hot. But now this is cold front conditions. Okay, if ever, meaning that if ever you're experiencing this cold front, you're going to experience low temperatures. The second one is that the pressure decreases but increase with the cold sector. So during this low pressure system, okay, which is a mid-light cyclone, the pressure decreases, yes, because it's a low pressure system. Okay, yes, but but it increases with the cold sector. The cold air is very dense, guys. Okay, the cold air is very dense and so on. So if ever it's very dense, meaning that it has high pressure, so the pressure is going to be increased in the cold sector. Okay, yes. Humidity decreases, you know, only warm air that has humidity. Okay, yes, that has moisture content, that has moisture. So the humidity decreases, meaning that with this cold air, the humidity, meaning that the moisture within it decreases, it becomes dry. Okay, yes. So the cloud cover increases. You know, on the ground there is domination of this cold air, meaning that the warm air is being pushed up to rise, okay, or to evaporate, to form some clouds. Okay, so the cloud cover under this cold sector or under this cold front conditions, the cloud cover increases in that way, as I explained. So the name of the cloud that are going to be formed are big clouds that are called cumulonimbus clouds that can cause up very heavy rainfall, and or we can say torrential rainfall. Okay, yes. So yes, that's how it goes under the cold front conditions. I think we have two. Okay, so under cold front conditions, chances of precipitation increases, you know. Okay, so we have these cumulonimbus clouds that are being formed, chances of precipitation increases, heavy rainfall can be received, or a snow. Even it's winter, guys. Okay, yes. So in winter, you know, a snow is possible. Okay, yes, because this air is very cold and dominant. Okay, wind direction changes and stronger winds. So the wind direction of this system changes and stronger winds are being formed. That is why Cape Town during winter when experiencing this mid-light cyclone, there will be destruction of infrastructure, buildings, destruction of houses, homes of people living in Cape Town. There will be, yes, a lot of destructions and so on. And this wind also put down trees, yes, can also rip down trees and other things that on the surface, on the ground. So that's how it goes. So cold front, under the cold front, if ever under the cold front, you're going to experience stronger winds. That's why the cold front, when passing through Cape Town immediately receive these stronger winds during winter. Okay, yes. If ever I'm pronouncing the word in a correct way, I think those winds have given a special name which are called caprions. Caprions, yes, caprions, because these are the winds of Cape Town. Okay, in winter, I think they are caprions. So everyone must stay inside the doors during this passage, or this passing of this cold front. Okay, yes, because there will be strong winds and so on. So even this wind can take people uh, from the other place to other place. Okay, yes, and injure people and so on. Okay, so people must stay inside or stay indoors when the cold front is passing through Cape Town and so on, or other places that are experiencing this midnight cyclone. Okay. Okay, now let's move to warm front conditions. Okay. Okay, warm front conditions, the temperature increases. This is a warm front. Warm means also means hot. Okay, or partially hot. Okay, I can say partially hot. Yes, not hot because hot air is very hot, but warm air is partially hot. Yes, it's not hot. Yeah. So the temperature increases. So the temperature of the air under this warm front, or in the warm sector. So in the warm sector, the temperature of the air is increased, meaning that the temperature of the air, or the air is warm, is partially hot. Yes. So the pressure decreases. Okay, the pressure decreases. Um, you know that the warm air has a low pressure. Okay, is less denser. It's going to cause a low pressure. Okay, meaning that it's going to evaporate. It's going to go up and up because it has humidity and less denser. Okay, yes. So the pressure decreases, while, as you know, on the other side of the cold sector, the pressure increases, or there is high pressure on that side. But in the warm front conditions, the pressure is low. There's low pressure. Okay, yes, the pressure decreases. So humidity increases. Warm air, I mean, has moisture content. Okay, has some water droplets. Okay, yes. So the humidity of this air on the warm front sector, or on the warm sector, there is high humidity. Okay, yes. Cloud cover and nimbostratus, meaning that there was not much evaporation that took place in the warm front. Okay, yes. So there will be little clouds that are being formed, which are called nimbostratus clouds. Okay, little rainfalls are being experienced and so on. So the precipitation, soft soaking rainfalls, as I said. Okay, yes. So the precipitation that is going to be received under the warm sector, or the warm front conditions, is going to be soft soaking rains, little rainfalls. Okay, very little, very little. Okay, let's go down to cold front occlusion. Okay, so what is cold front occlusion? The cold front occlusion, this is whereby the cold front overtakes the warm front. Okay, yes, meaning that there will be dominant um cold air on the ground and so on. Okay, yes, the fronts before normally in the mature stage of the mid-light cyclones were like this. Okay, were like this. There's a cold front. Okay, it's going to be a warm front. Okay, this is a warm front this side. Okay, so this is a cold front. I'm just going to write C. It's a cold front. This is a warm front W. Normally it was like this. Okay, so as you can see in this picture, now there's something different there. That's a cold front occlusion. Okay, this is whereby this cold front has increased its length. Okay, has increased its length. Okay, meaning that it's overtaking the warm front. Okay, yes, meaning that it's dominant. It's being dominant, meaning that the air that is dominant there, or the air that is dominating is cold air in that system. Okay, yes, so this is why cold front overtakes the warm front. Okay, let me remove that so that you don't look there for quite long. Okay, so the temperature in front of the system is higher than behind the system. So in front of the system, as you can see, this is a warm front. Okay, meaning that the conditions that are going to be under this or around this warm front, there will be warm air. Okay, and this system is moving from west to east. Okay, from west, so it's moving from west to east. Okay, as you can see, so in front of the system there is warm air, as you can see. Okay, behind the system there is cold air under the cold sector. Okay, yes, so temperature in front of the system is higher than behind. Warm air has higher temperature than the cold air. Cold air is low temperature. Okay, that's what is meant here. So the cold front cuts into warm front, as I showed you in the diagram. Okay, as you can see here, this cold front cuts into warm front, increasing its length and becoming dominant. Okay, yes, so let's move, yes, to warm front. Let me just okay, let's move to warm front occlusion. So warm front occlusion, this is whereby the warm front overtakes the cold front. This is a vice versa. Now, okay, this is something opposite than what we have discussed. Okay, you know that in cold front occlusion, this is whereby the cold front overtakes the warm front, but now this is a warm front occlusion. Warm front overtakes the cold front, as you can see in the diagram. Okay, that the warm front has increased its length, cutting through this cold front. Okay, now things changes as this warm front cuts into the cold front. So the temperature in front of the system is lower than behind the system. So meaning that if ever the warm front is cutting through the cold front, underneath just behind the system, there will be, or the air temperature is going to decrease, because you know that there was warm air. Now the warm air is going to force to rise, to go up, and the cold air is going to be dominant on the ground. Okay, yes. So that's how it goes. So in front of the system there will be cold air, and behind the system will be cool air. Cool air is partially warmer than the cold air, or the cool air is warmer than cold air. Okay, yes. Cool air is also kind of like cold, okay, but not cold, like it's warmer than cold air. Okay, yes, I can put it that way. So cold air in front of the system, and behind the system there will be cool air. So the temperature in front of the system is lower than behind the system. That's what it is meant, yes, by this diagram. So the warm front cuts into cold front, as you can see that the warm front has cut into the cold front, resulting into this scenario whereby the temperature now in front of the system is lower than behind the system. You must know that, guys. Okay, you must know that very, very well. It's going to come out during examinations. Please, 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 please don't forget what I told you. Okay, so the satellite. This is the satellite photo of a mid-latitude cyclone. Satellite photo of as you can see the movement. Okay, the movement of a mid-latitude cyclone from west to which side? To east. Okay, yes. Okay, this also says that northwesterly winds, high temperature, few or no clouds, no precipitation, high pressure. Okay, in the interior, in the much interior of South Africa. So this is a low pressure system, as you can see. This is a low pressure system, which is called mid-latitude cyclone. Okay, yes. So as you can see that the cold front is approaching South Africa, or has approached South Africa. Okay, is passing through South Africa. Okay, so South Africa is going to be affected, and so on. And also you can see that this cold front has large number of clouds, has big clouds of a line around them. Okay, yes, that's a front. Okay, yes, which are cumulonimbus clouds, but the warm front has like clouds that are not fixed together. Okay, small clouds, condensed, and so on around, meaning that those are nimbostratus clouds, have little rainfall. But in this side of a cold front, there will be very, very heavy rainfall. Torrential rainfall is going to be released, and so on. And you know the common core weather conditions under the cold front. Okay, yes. So the movement of the cyclone from west to east, as you can see. So this is a satellite photo of mid-latitude cyclone above. Okay, yes. So that's how it goes. So in this side, southwesterly winds, low temperature, high cloud cover, precipitation, low pressure. Air keeps rising on this side because the cold air is becoming dominant. Okay, yes, on the surface. Okay, let's go down to the synoptic map of a mid-latitude cyclone. This map is the one that is mostly used during examinations. This, I think you know. I think you also know that. Okay, so this is a synoptic weather map. Okay, synoptic weather map. Okay, and this is the one that is mostly used. As you can see there is high pressure, but as we move from east to west, pressure decreases. Okay, meaning that we are going to experience a low pressure system. Okay, from 1032 hectopascal to 996 hectopascal. Okay, this is a low pressure system. As you can see, the cold front, okay, cold front passing through South Africa, hitting very well the western side, the southwestern side of South Africa. Okay, yes, and I think you can see that. Okay, let's talk about this, about B. Okay, about this low pressure system B. Okay, I think you can see that this is a cold front. Okay, let me remove this so that you can clearly see that yes, this is a cold front, because I'm preventing it from being okay. So this is a low pressure. There's a low pressure 908 hectopascal. Okay, low pressure system. As you can see, this is a midnight cyclone. There is a warm front and a cold front. Okay, yes. Just behind the cold front, in the warm sector, by the way. Okay, let me erase. So in the warm sector, you can see that the cloud cover overcasted. Okay, the skies overcasted. Okay, the clouds. Okay, yes, and so on. There are very, very huge clouds there that are being experienced in the cold sector, just behind this cold front. Okay, meaning that there are cumulus clouds there. Okay, yes, but clear skies in the interior of South Africa. Okay, clear skies, Port Elizabeth, clear skies, Durban, Maputo in Mozambique. As you can see, Pretoria and Gauteng, and all of these northern parts, northern Cape as well. As you can see that these are um these areas are experiencing no rainfalls and so on, but southwestern areas or regions of South Africa are experiencing these mid-light cyclones. There are clear skies here. As you can see, there will be no rainfall because these areas are not being affected by mid-latitude cyclones. I think that's how it goes, guys. Please, guys, please, if ever you didn't subscribe, please subscribe. Okay, please subscribe to the channel so that you can grow, guys. I think that was amazing lesson. um See you next time. Cheers.